In this KutaSoftware Infinite Pre-Calculus free worksheet, we're going to be evaluating limits at essential discontinuities. So let's look at number 1. We're going to be evaluating the limit of x squared over 4x minus 16 as x approaches 4. Now we know if we were to plug 4 in for x, we would get 4 times 4 minus 16, and 16 minus 16 equals 0. So our function is undefined at x equals 4. And you can see that when x equals 4, we have a vertical asymptote. So going from the left as we approach 4, so from the left side, we're going closer and closer to negative infinity. And approaching 4 from the right side, we're going closer and closer to positive infinity. So because positive infinity does not equal negative infinity, this limit does not exist. So in number 1, the limit as x approaches 4 does not exist. Let's look at number 2. For number 2, we can recognize that if we plug negative 1 in for x, we'll get 1 plus negative 2 plus 1, which would be 0. So at f of negative 1, we're undefined. You can see that we have a vertical asymptote at negative 1. So as we approach negative 1 from the left, we're getting closer and closer to infinity. As we approach x equals negative 1 from the right side, we're getting closer and closer to positive infinity as well. And because both are approaching positive infinity, we do indeed have a limit, and that is positive infinity. And number 3, we're finding the limit of negative 2 over x minus 2 as x approaches 2, and that's as x approaches 2 from the left. So as we go towards 2 from the left, we're going towards positive infinity. So positive infinity is our solution in number 3. Now, if it asked us to find the limit as x approached 2 from the right, that would be negative infinity. And if it asked us for the limit as x approached 2, because infinity does not equal negative infinity, the limit would not exist. But it asked us for the limit as x approached 2 from the left, which is positive infinity. Now in number 4, it asks us for the limit as x approaches negative 4 from the right. So coming from the right-hand side, or the positive side, approaching negative 4, you can see that we're heading towards negative infinity. So our solution in number 4 for the limit is negative infinity. You can also see that if we approach negative 4 from the right, we're also approaching negative infinity for f of x. Therefore, because the limit as x approaches negative 4 from both the left and right is negative infinity, even if this stated the limit as x approached negative 4, we would still have an answer of negative infinity. Now let's move on to number 5. In number 5, we have the limit of negative 2x over x plus 3 as x approaches negative 3. And there's 2 different ways we can go about this. First, we can plug in points in a t-table, having values that approach negative 3 from the left and values that approach negative 3 from the right, and see if those are equal. Or we can graph and look at the graph. Let's go ahead and graph so we can see this visually. Here I have my graphing calculator, and I'm going to type in negative 2x over x plus 3. I'll make my graphing calculator a little bigger. And we're looking at the limit as x approaches negative 3. As we approach negative 3 from the left, we're getting closer to negative infinity. And as we approach negative 3 from the right, we're getting closer to positive infinity. So because positive infinity and negative infinity are not equivalent, then our limit in number 5 does not exist. And again, that's because the limit as we approach negative 3 from the right does not equal the limit as we approach negative 3 from the left. Now moving on to number 6, I'll graph this as well. So we have x minus 2 all over x squared minus 10x plus 25. You can see we have a vertical asymptote at x equals 5, and as we approach 5 from the left, or from the negative side, we're getting closer to positive infinity, and as we approach 5 from the right, or from the positive side, we're also getting closer to positive infinity. Therefore, in number 6, our limit does exist, and that limit is infinity. Now, on to our last problem, our critical thinking question. For number 7, it says to give an example of a right-sided limit that goes to infinity as x goes to 2. So it's important to note that this is a right-sided limit. So it's the limit as x goes to 2 from the right-hand side, which is the positive side. So we're finding the limit of some function f of x as x approaches 2 from the right. Now, in order to get that vertical asymptote, we need to have the denominator equal to 0 when we plug in a value of 2 for x. And that can occur when we have x minus 2. Because if we have x minus 2 and we plug in 2 for x, we'll have 2 minus 2, which does indeed equal 0. Now we just have to figure out what the numerator should be. And it's simple. We can just plug in a positive 1. Now, if we're looking at our t-table of x and f of x values, approaching from the right, I'll start with 5, 4, 3, and then go to 2.5, and so on. So plugging in 5, we'll have 1 over 5 minus 2, which is 1/3. Plugging in 4, we'll have 1 over 4 minus 2, which is 1/2. Plugging in 3, we'll have 1 over 3 minus 2, which is 1 over 1, or simply the whole number 1. Plugging in 2.5, we'll have 1 over 2.5 minus 2, which equals 1 over 0.5, or 1/2, and 1 over 1/2 is going to be 1 times 2 over 1, which is 2. So you can see my values are getting larger as we're approaching positive 2 from the right. So this limit will go to infinity as x approaches 2 from the right. And let's double check this on a graph. So we'll plug in 1 over x minus 2. And you can see that as we approach 2 from the right, we're getting closer and closer to positive infinity. And you can see some of our values that we plugged into our t-table, such as 4 and 1/2 and 2.5 and 2. And it's important to note that that numerator has to be positive, because if it was negative, say -1, then coming from the right, as we approached 2, we would get closer to negative infinity. That is why we have a positive 1 over x minus 2. So again, one of the answers for number 7 is the limit of 1 over x minus 2 as x approaches 2 from the right. If you have any questions, please feel free to leave them in the comments below. And as always, don't forget to like, subscribe, and share. Also, feel free to support me through my Patreon page. And if you want more information, go to my website, maemap.com, maemap.com.